Hello class, now we're on to lesson 10-6. The title is to find segment lengths in circles. So now we're talking about different lengths that we might have inside of a circle. Our first theorem, 10.14, is talking about two chords. And they intersect inside a circle in our first example. So if that happens, the product of the segment lengths of one chord is equal to the product of the segment lengths of the other chord. So if I'm looking at this chord right here, or let's talk about AB all the way across, then the first segment, EA, times the second half of it, EB, is going to equal the segments, when they're multiplied, of the second chord. So ED times EC. And that's it. Pretty awesome. Okay, I love that rule. Our next theorem is theorem 10.15 or 10.15, and it says if two secant segments, so they're not chords this time, they're secant segments, share the same endpoint outside the circle, so that would be point E, then the products of the length of the entire secant times the external segment is going to be equal to the other product, the entire secant times just the external segment. So let's write that down. So this means that EB, so that entire secant, times just the external part, EA, is equal to the entire other secant, which is ED, times just the external part, EC. And that's it for that rule. Okay. Let's move on to our final theorem for today. Theorem 10.16 says, if a secant segment and a tangent, so this time I have a secant segment and a tangent, share an endpoint outside, so this is kind of similar to what we had before, except now one of the segments is a tangent, then the product of the lengths of the entire secant segment and its external segment is going to equal squaring the tangent segment length. So that means that ED, so the entire secant segment, times the external, EC, is equal to simply squaring EA. Okay, so just before we go, I have 3 practice problems for us to try, and this is where your algebra skills are going to come in. Okay, so for our first part, we need to find RT, so this whole length of that chord, and SU, so the length of that chord. And to do that, obviously, we need to find X. So we were told that the product of those two segments should be equal to the product of the other two segments. So why don't we go ahead and do that? So 3x times x plus 1, so those are the two segments on RT, should be equal to the product of x times 4x. So let's go ahead and do some multiplication. 3x times x is 3x squared, and 3x times 1 is 3x, and that's all equal to 4x squared. So let's see if we remember how to do this. We're going to have to do some factoring to solve for x. So I'm going to subtract everything, move it all to the other side. I'm also going to subtract 3x to move it over. So I have 0 equals, that just leaves me with x squared minus this floating 3x, because all that crossed out. Okay. Now in factoring, I can look to see what can I pull out. I can take an x out of both, and I'm left with x minus 3. So now let's try to see, okay, what would x equal if I set them each equal to 0? This first one is just going to be x can be 0. The second one, x minus 3 equals 0, tells me When I add 3 to both sides, x can equal 3. So which one of these would work? Let's figure it out. If I plug 0 in, that means that this length is 0, this length is 0, this length is 0, and this length is 1. So obviously that's not going to work. But let's try 3. If I plug 3 in, do I actually get some lengths? Yes, I do. So let's find RT first. RT is the sum of x plus 1 plus 3x. Right? So let's go ahead and plug in the 3. So 3 plus 1 plus 3 times 3. So that's 4 plus 9, which is 13. So I found that the length of RT is 13. And then let's do SU the same way. SU is the same as x plus 4x, which is 3 plus 3 times 4 is 12, which means that SU is 15. So you have to remember your algebra for this problem. Okay, here's our next example. As you can see, these are two secants, and they are meeting outside of the circle. So, what we learned was the product of the entire secant times just the external part should be equal to the product of the entire secant times just the external part. So what would the entire length be here? Well, that would be adding up everything. So that's going to be 3 plus x plus 2. And if I want to multiply it by the external, that's going to be times just 3. I'm going to go ahead and put that in the front, okay, because I like having the number right in front. And then when I add all of those up, I have x plus 1 plus x minus 1. And I'm going to multiply that just by the external part, x plus 1. Okay, so let's go ahead and clean this up. This is really 3 times 3 plus 2 is 5, so x plus 5. And on this side, I have x plus x, which is 2x. And 1 minus 1 is 0, so there's nothing left there, times the x plus 1 in the other parentheses. So let's work this out. Distributive property, 3x plus 15 equals 2x squared plus 2x. So now we need to go back to factoring. Let's move everything to one side. So let's subtract the 3x. And let's subtract 15. So all this is 0 on one side, and I have 2x squared minus x minus 15. So this goes into factoring, which you might need to brush your knowledge on. But one of these is going to be an x, is going to have to be an x. The other will be a 2x. So the x times 2x can be 2x squared. And then I'm thinking, what two numbers, when I multiply them, do I get negative 15? Well, let's see, that's going to be negative 3 and positive 5. Because this way, negative 3 times 5 is negative 15. But also, when I do FOIL, it adds up to negative x, right? Negative 3 times 2 is negative 6x plus 5 times x, which is 5x. Negative 6 plus 5 is negative 1. So same thing we did before. Let's set them both equal to 0. So x minus 3 equals 0. And also 2x plus 5 is equal to 0. Here, see the x equals 3. And here I find the x equals negative 5 halves. Well, looking here, if I have a negative number that I plug in, then the length is going to be negative. So I know that that's not going to work out. So I found that x equals 3. This is my final answer. Okay, one more example and then we're done. This time I also want you to find x. It has a tangent and a secant. So what we learned here is that if I multiply the entire length of the secant times only the external part, that that is going to be equivalent to squaring the tangent. So let's do some distributive property. This is 14x plus x squared equals 225. I'm going to rewrite it and move everything to one side so I can do some factoring, which is your favorite thing to do. X squared plus 14x, I'm just swapping the order, minus 225 equals 0. And if you recall, I'm looking for two numbers that when you multiply give you negative 225, but when you add give you 14. So one's going to be a positive, one's going to be a negative. It's going to be 25 and 9. So when I set these equal to 0, I'm going to find that x is going to either equal negative 25 or x is going to equal 9. So again, can't have negative as any length, so your final answer is 9. So come with any questions you have when you come to class, and I'll be ready to help you.